Hello my YouTube friends, today we look at some of the examples in motor braking, and the question I have here says a 25 horsepower 230 volts 92 amps shunt motor has an armature circuit resistance that is 8% of the voltage over current, and then you are asked to calculate the ohmic value of a dynamic braking resistor that will limit the braking current to 200% of the rated value, assuming that braking is initiated when the motor is delivering a 18,650 watts load. Now, such questions, first we have to understand a few things that I've put up here. You remember that what we are trying to achieve here is to achieve generation mode, so that the motor goes on generation. And when the motor goes on generation mode in dynamic braking, what we experience is that there's a counter electromotive force that is generated in the windings, and that counter electromotive force opposes the applied armature voltage, and it starts to limit the armature current, and in so doing it decelerates the motor speed to a halt. So what will happen in this circuit, you see the armature here, and you've got a resistor, what we call the dynamic braking resistor, and then you've got the shunt field like so, and in the process what happens is basically disconnection of the shunt field to the resistor, and that resistor now brings about the limitation of the armature current, and in so doing you break the motor. So what we use is the total voltage that you can find in this circuit as seen is found from VC plus IARA. Now VC is the counter EMF that is induced in the armature, and then this is the armature current and the armature resistance, and then VT is simply the supply voltage. And then we look at this further, so we can find from that equation, we can find the dynamic braking resistor to be equal to VC minus IARA over I. Now we are saying this whole value, that is VC minus IARA, is the armature voltage at start of braking. So this voltage, once we know this voltage, divided by the current, the dynamic braking current, which we can also call the inrush current, then we are able to determine the size of the dynamic braking resistor that we require. In other words, if we know the value of the inrush current, this is basic simplification of this equation, we can then say VC over the I inrush, which is the dynamic braking. Here the I cancels, almost the same current, and we remain with simply RA. So we are able to determine the dynamic braking resistor from this equation. Now let's look at our equation, our question. So the question is to find the ohmic value of the dynamic braking resistor, and for us to be able to do so, we have to find, we've been given the full load current in this circuit is 92 amps, and then we've also been given that it's a 230 volts supply voltage, and we have the inrush current can be found, we've been told it's the braking current has to be limited to 200% of the rated value. So we've got 200%, so the inrush current or the braking current is therefore equal to 200% of the full load current, and the full load current is 92. So when we solve this, we've got 200 over 100, that multiplies by 92 to give us 184 amps. That's our inrush current. And then we also know that our armature resistance has been given as 8% of the volt-ampere relationship, or voltage over current. And that implies that we've got 8 over 100. This multiplies by the voltage, which is 230, over the current, which is 92. So we're using the full load current in this case to get the armature resistance. And the armature resistance in this case will be 0.2 ohms. Now, once we know the armature resistance, and we know that our VC, then, if we make the subject of the formula, is the total voltage or the supply voltage, this is going to subtract now the full load current that multiplies by the armature resistance. And then from there we can determine this. We know we have 230 volts, so we determine the counter EMF voltage. So 230 volts minus the current, full load current, is 92. That multiplies by 0.2, and this gives us a counter EMF of 211.6 volts. 211.6 volts. So therefore the dynamic braking resistor value can then be found from VC over I inrush, and that subtracts the armature resistance. And our VC in this case is 211.6. This is divided by the inrush current, which is 184 amps, and that subtracts the resistance, the armature resistance, which is 0.2, and this gives us the value of 0.95 ohms, meaning that we need to find the resistance that we need to place in the circuit to achieve or to limit the to achieve braking when there's a load of 18,650 watts, is simply equal to 0.95 ohms. So this is how you get it. So if we go back here, our solution in this case, our solution is that the dynamic braking resistor should be able to be 0.95 ohms, and that's what we obtain when we have this relationship or solution. The second question says we have a 15 horsepower 230 volts motor that has an armature resistance including brushes of 0.38 ohms, and when operating at rated load, armature current is 54 amps. You are to calculate the value of a plug-in resistor if the armature current is to be limited to 1 3/4 times the full load value at the instant the motor is plugged. In this case, we are assuming that the counter EMF is 90% of the applied voltage at that instant. Then this is for my student, second section is for the motor in 1, which is what I've just read above. Calculate the resistance of the dynamic braking resistor if an armature current is to be limited to 1 3/4 times its rated value. So I'll expect you to solve the second part of the question, but let's look at how we solve the first part of the question. Okay, so we're looking for the plug-in resistor in this case. It's not the dynamic braking resistor, and we find the plug-in resistor from the sum of the total voltage or the supply voltage plus the counter EMF voltage, and this is divided by the inrush current or the braking current, and this subtracts the armature resistance. Now in the question we've been given a number of information. We've been given that our armature resistance combined with the brushes is 0.38 ohms. We've also been given that the value of the counter EMF is 90% of the supply voltage. So VC is equal to 90%, that's 9% of the supply voltage, which gives us about 207 volts. And then we've also been told that we are to limit the armature current to 1 3/4 times the full load value. So having been given the full load value of current, in this case to be 54 amps, what we do to find our inrush current, I inrush is therefore going to be equal to 1 3/4, which is basically 175, multiplied by the full load current, which has been given as 54 amps. And this gives us the inrush current to be 94.5 amps. So this is the inrush current or the breaking current. So we find now the plug-in resistor value, which gives us, we've got 230 plus 207 over the inrush current, which is 94.5, and this takes out, so we're looking at this value of resistance here, subtracting, so it's the general resistance in the system minus the resistance in the armature, which is which has been given as 0.38 ohms, and this gives us the plug-in resistor value to be equal to 4.25 ohms. So this is the plug-in resistor value that we need to put in the circuit to achieve breaking by limiting the starting resistance, or sorry, by limiting the armature current to 1 3/4 of the full load value. Now, to my students, you are going to, or those that are interested, you're going to find the second portion or the second part of this question, which is this part of the question. This, I leave it for my students to find the answer and share the solution in the comment section below. So for this part, we are saying we found the plug-in resistor to be equal to 4.25 ohms as our solution. So what is the dynamic braking resistance that you need to find here? And let's compare in terms of levels of resistance, which one will be higher and which one will be lower to stop. Remember that plugging is basically the reversal of the running of the motor, so that it stops using inertia, because it is going to continue running until it reaches a halt, but before it is reversed, starts to run in reverse, it is cut out of the supply voltage and the motor stops running. Okay, so thank you for watching. I hope to see the solutions for the dynamic braking resistor here, and please add your comments or any questions that you have to the comment section. I'll see you next time.